We should be live. We are live. Okay, so good. Let me change the title. So start compilation to x86 from our stack-based VM in Objective-C. That's a good title.
Like, it looks like a space filling curve, but it's rounded instead of squarish.
I see. Okay, so let's first say what we did in the after the previous recording, right? So we implemented strings, right? So now you can have stuff like this.
By the way,
Uh,
hi future people.
yeah, hi future people, and hi past us. Um, well, actually, hi
How would
future
the past
us.
us watch
Actually, it's
this?
hi
Like,
future us because we're gonna watch this in the future if you need to. Actually, okay.
like, do you have a time machine for the past us to watch this?
That would be great, wouldn't it?
Good,
Um,
yes.
so we implemented this thing which allows you to have strings, literals now. So now we have two types of literals. We have numbers and we have strings. And this was very complicated to implement because this completely broke the idea of each line is a word in
A
memory,
memory cell,
a memory
essentially.
cell, right? Which is bad because it was pretty good like that, and this can be arbitrarily sized. So we added to the memory the length of this, and every single function in Chime that requires understanding strings, they're gonna have to deserialize the strings. We made functions for that. So one very good example is the read syscall, right? So we also finished implementing the syscalls. So this is now the read syscall, and this is the write syscall, and we removed the other ones because we don't think we're gonna use them. And this is manipulating strings. Why? Because originally in C, the write and the read syscalls, they expect char star or char star star or something like that. And now that we have strings, we can fulfill that requirement, which is great. So then these programs now work. Programs like this, and of course you're gonna have to initialize the string, right? And that could be pretty annoying. So it would be kind of nice to have some sort of, I don't know, a syntax sugar, so you don't have to do this yourself. You could put, I don't know, some sort of identifier like a string and then 25. We're not gonna bother with that right now. Right now, you're gonna have to do it yourself, uh, which is good.
Oh, by the way, we don't have escape sequences yet,
Oh yeah,
Adam.
we also don't have escape sequences, and we tried very hard to add those, but it didn't work. We're gonna have to think how to do that later. Uh, Aside from doing like the grug thing of like linearly iterating through the string and
Like,
converting and adjusting the size.
yeah,
Uh,
like if it was just interpreting the escape sequences, that's pretty easy. But then we need to know the size of the string in order to parse the program, right?
yeah.
And with escape sequences, we
No,
don't
but we
have a
could make the
strict.
parser have the responsibility, Marin. We could read it, and before writing the length and the bytes packed into words, we could do a translation layer that would change the string from the original one to the escaped capable one, and then collect the length, and then write it down, right?
That's true. That's true.
Or you can do this interpretation only when you're going to use the string, but I think that's kind of bad. I think the parser should do that. Anyway, so today we're gonna start compilation, right? So you have a Chime program. You're gonna pass a flag to the to the now compiler Chime compiler, and it's gonna compile a Chime in program in an assembly Chime program, or even why not a bytecode Chime, although that's really not the scope of today, but why not? You also provide like an already compiled bytecode of Chime, and you want to transform that into x86 bytecode, right?
Yeah, and I immediately have a question. How do you deal with self-modifying code?
Yeah, and then Marinho asked that, and we're gonna try to understand what he means by that. And he provided me an example of a program. There apparently does that, although I doubt it. But let's go. Uh, so let's go to, I don't know, scratch buffer. Here's the program. Go.
So yeah, you have some blob, which is just location in memory with some code, and then somewhere in the execution, you push some number to the stack. You may compute it. Doesn't matter how you get it, just that you have it. And then what you do is you write that number to the location where some blob lives, and then you jump into it, effectively executing code that you just wrote into memory.
Yeah, we're gonna do exactly how we do in Chime.
We don't do this in Chime yet, in the sense of like compiling stuff.
No,
Like,
no, no,
don't
no.
get me
We're
wrong,
gonna
this
do
actually.
exactly how we do interpretation, and I'm gonna explain how. So my idea is, at least in the first moment, to try to, instead of trying to map the Chime abstractions such as the stacks and the registers straight up to the best possible version in x86, why not make a very dumb way, or very grug way of doing that? So what do I mean? So I thought about reserving a section of memory in x86 assembly, like I don't know, FASM or whatever, and then using that as the memory, right? That will be the memory of the Chime memory. It's going to be a one-to-one correspondence. And how we're going to map the registers, and how we're going to. I thought about also allocating some memory in the FASM or FASM, and there's an other compilers of assembly anyway. Uh, and then we would just have, I don't know, a memory region. So let's see. Let's actually see how that works.
But
So
then that's not really a compiler because it still has to interpret the Chime instructions.
no,
It's only a
it's
compiler in the sense that fourth compilers are compilers.
no, it is a compiler in the sense of like you're gonna grab a Chime program written in a Chime dialect, and you're gonna get a FASM bytecode out of that. That's my idea. And how we're gonna do that? You're gonna have a Chime program. We're gonna transform that to a FASM program, and then we're gonna use FASM to compile that, and then we're gonna have FASM bytecode. .o probably, or something like that. And then this is going to be the way that you're going to have the native executable, because that we already have FASM, right? So this is actually a native executable. I think what you are proposing, maybe I'm getting that wrong, is to maybe go from a Chime program going directly to native executable.
Lemus,
Go.
in your FASM program, you have your text section, right?
Yeah,
And you have your instructions there.
yeah,
That's data. That's binary on the memory. Could you modify one of those instructions at runtime?
yeah. But that's not what we're gonna do.
No, no, that's the self-modifying code he means, I guess.
Yeah, that would
Yeah.
be one way to do it. That's not the way that I'm proposing to do it because I don't know how to do that. It's
So
just simple
basically,
as
what
that.
you're proposing is actually that instead of having to rely on the Objective-C binary to run a Chime program, instead we compile a very simple interpreter in assembly, in a native assembly, x86 assembly, and then we package the Chime program with that, and then we actually don't need the Objective-C compiler just to execute the Chime code anymore.
Yeah, there's a trade-off there, you see, right? Because now we are adding an extra dependencies of having an extra compiler alongside the toolchain.
And at that point, it's probably just easier to improve the elevator chime implementation to have feature parity with the current chime.
I don't see the correlation between that statement and what we are talking about, but sure. Like if the elevator chime version will have to do the same thing if it's gonna follow the same idea. Because I think what you propose, Mani, is a lot harder, which is to go from a Chime program
No, but
directly to the x86 bytecode. That's very hard
but
because
here's
you're gonna have to
but
understand how
like
that
here's the
works.
yeah, but here's the thing: the elevator chime version already reserves memory in the way you are proposing to doing the FASM implementation. That's why I said
Already
it would be easier.
allocates. I think you are confused. Let me try to explain. Um, so in a Chime interpreter, we have a few data structures being used, right? We have a stack. We
Yeah,
also have registers,
yeah.
and we also have memory, right? Actually, have more than one stack, so I'm gonna put stacks, right? Uh, you're right, Nathan, but I'm gonna go there. So we have this thing, right? My proposal is to basically transport these data structures to low-level versions of them in FASM. Why? Because it's a
Yeah,
lot
but
easier. What
yeah,
I
but
think
my
you are
point is
proposing is to
no, but
make
my
a
point is
Chime compiler that goes straight up and understands how the format of the native bytecode works.
like my point is that the Chime interpreter that you wrote there, that you plan to transplant to a lower level representation,
Yeah.
the elevator time version already uses that lower level representation internally because it's just easier to do it in Zig than it is in Objective-C.
Yeah, I'm still confused by what you mean by that. So in an elevator chime, which is the okay, so let me put this in context for people that don't know what that is. So elevator chime is um, alternative
It's a Zig,
version,
yeah,
uh,
it's a Zig version of
s-
Chime that I wrote over a
alternative
weekend because I
subset of
felt like it.
chime written in Zig,
Yes, and it's written in Zig.
which
Uh,
is okay. So let me ask you this. So in elevator chime, can you create an executable, like an ELF executable, or of a Chime program?
Not yet. Like that's kind of the point I'm trying to make. We could definitely do that because I think with Zig's compile time metaprogramming, we should be able to like read and compile time program at Zig's compile time and just embed that in the executable that we emit when we compile the code. So that should be relatively easy to do actually.
Okay, but that
Yeah.
that feature could be done without understanding how the executable would be made. It would be something out of the box from Zig. Am I
Yes,
understanding this correctly?
yes, you are.
Okay, so it would be a way to get an ELF executable without having to know how the format works, because Zig will do that for you.
And it would be a cross compiler as well because Zig makes cross compilation very easy.
Well, in this case, we also have cross compilation because FASM has cross compilation, but it is really interesting and really that much better if it's
No,
true,
no.
if that holds.
What I mean is that like FASM is x86 essentially, right?
Yeah.
Zig can compile to x86. It can compile to ARM, to WASM. It can compile to PowerPC. That's what I mean by cross compilation.
No, no, no. But I think there again there is some confusion. So um, Objective C, Objective C is compiling to x86 a native Chime interpreter, right? A
Yeah.
native Chime interpreter. You are saying that Zig can create um, a native Chime compiler that creates a native executable, but you don't have to know how that happens. That's what you're saying to me.
Yes, because we already have the compiler, quote unquote, that takes the assembly files and turn them into Chime bytecode, right?
Yes.
That's just a function, but in Zig you can call arbitrary functions at compile time. So nothing stops me from passing a Chime program as a compile time flag, and then
Oh, I think I see what you're talking about. So you were essentially changing the target.
yeah, like I can take the
I
Chime program
see.
as as a compile time flag, and then at compile time I can compile this to Chime bytecode and produce a memory image, um, and have that embedded in the executable that the Z compiler will spit out.
Wait, can't do you know the term to search for that? Because now I'm very curious. Is there a way to do that in Objective-C? How would you search for that?
You would have to do the Zolding thing that he was doing in that video you showed me recently, where like
No, no,
he's
no, but that
taking
no, but no, you have to do that. Let me also explain for people that doesn't know what you're talking about. So there is a video of Zozing in which he's exploring the bytecode format in order to create, I think, a brainfuck compiler, right?
like he's basically taking an
Instruction?
arbitrary binary file and converting it to C source code
Yeah.
into an array literal, basically.
Yes. Really. Yeah. Yeah, but I want to see if the capability that you said that Zig has, which is that you don't need to care, because we don't know Objective C, right? We are learning throughout the journey. So how would you search to see if Objective C has such a feature?
Well, first of all, Objective-C doesn't have arbitrary compile time coded execution
I don't know that information. That's what I'm
because
asking.
it still uses the C preprocessor, right? But that's fundamentally a separate language from C, or Objective-C in this case.
I understand that you have very or good oriented guesses that it doesn't support it, but I want to try to search it. So what that would be?
Okay, I don't know.
Compiler time what? Functions in Objective C?
Metaprogramming, if you want to use the fancy technical term, I guess.
What profiling has to do with the question? Oh, they have a fancy UI for that. That's good to know. Okay, so what is the another way to understand that? To set to search that?
Objective-C metaprogramming.
How to use metaprogramming?
Oh, but this is runtime metaprogramming. Compile
It has a
time.
reflection. If you realize that every property has a getter, you can do.
Yeah, but reflection is compile time metaprogramming. I mean, it's runtime metaprogramming. I'm talking about compile time, like code generation and that sort of stuff.
Okay, that's the term then. So code generation. There's no way. There's no freaking way. What is this? The Objective-C code generator. Focus on the interesting and pleasant things. Let the boring ones be auto-generated. The Objective-C code
Yeah,
generator.
Nathan said it's not the same. And it kind of isn't because in Zig that's actually integrated in the language
No, no,
itself.
no.
You
No,
don't.
yeah, but nobody is arguing it is the same, guys. I don't know why that comparison is being made.
I don't
Like,
know. Ask Nathan. He's the one who mentioned this. It's
again, I'm not arguing by any means or stretch of the imagination that there will be a one-to-one thing close enough to how Zig does it. But we don't know that information, Atan. You're saying that it's not executing code. We don't know if there is a way to do that. That's why we are searching. Oh, you're talking
the
about
thing
this
you are
thing.
looking at is just pre-processing. Yeah, it kind of is. It kind of is.
I see.
And it's not even written in Objective-C. It's written in Go.
Yeah, it's not self-hosted. Yeah, but I mean, That's expected nowadays. Come on. Is this recent? No. 9 years ago. I see. Okay. Okay, so what is the question on this one? How to use core data, gen classes, and Objective-C? That's not close to the question. Code generator. Okay, so there is also another thing. So compile time meta programming in Objective-C. We are exploring the waters. It's fine. Oh, this is just simple macros, my friend. Yeah. This is just simple macros. Runtime and yeah, but that's not Objective-C, people. Template metaprogramming. Okay, so it seems to me that Google has absolutely no idea what to do with this question, with this prompt. It has
I mean,
absolutely
C++,
no idea.
I mean, yeah, technically C++ has templates, but that's like, I have no idea how they work. And just from the name, I kind of don't want to know how they work because they sound gross.
Okay,
Just
so
use OCaml. Uh, oh, there's
it
Metal
no,
Camel. That's a thing,
I
right?
don't like PPX. I tried with Magetta
No, no, no,
more
no,
than
no, no, no,
once,
no, no, Metal Camel.
but that's not what he's talking about. That's not what Nathan is talking about. I really dislike the experience. That's not it what we want. Oh, this one is written in Objective-C. It's even older. Yeah, but what are the targets? That's okay. So you're basically generating what? Working on state tech. Very specific. Okay. Metaprogramming on Objective-C. Yeah, but this seems to be again runtime. And that's it. Reflection, that's also runtime. Okay, so there is Nathan sent a thing. Function execution is a ability of a compiler that would normally compile a function to machine code and execute it at runtime to execute the function at compile time. This is possible if the arguments of the function are known at compile time and the function does not make any reference to or attempt to modify any global state. Examples. Oh, I see. Wait. Objective
Oh, leave.
C to C++.
Okay, leave it to C++ to have two features that do the same thing essentially.
What do you mean to have two features?
Like in that link that Nathan posted about compile time function execution.
Yeah.
There are two examples in C++. Why are there two examples in C++?
Because one is using templates, the other isn't. Yeah, for sure that's the difference. This is using template and this is not.
But why do you have two features that do essentially the same thing?
There are historical reasons, and there is also the fact that they don't bother to, like, C++ probably goes against the entire Golang philosophy, which is that you probably have one or two, at max two ways of doing the same thing. So they probably have 12 ways of doing the same thing.
Okay, there's no mention of Zig in that page. I call it sus.
I call it outdated.
Also possible, yes.
I don't want to interrupt with C++, my friend. I want to compile Objective-C to C++. Because if there's a way to do that, that would be the most grug way of doing it. Objective-C to C++. Objective-C++. I forgot that this exists. And Mageta mentioned this. Mageta totally mentioned this. Yeah. Well, I guess generating C. Yeah, that's not really what I want. And this is runtime. Yeah, don't really care about that. Yeah, so I think you're right, Marinho. Well, you're right in one way, which is that probably doing this in Zig would be a lot easier because you don't have to basically do anything aside from changing the target. But I would say your way is less fun because we're gonna have to learn how real-world assembly is done in order to make this version, which has value in my opinion.
What Chime is an assembly, and it exists in the real world because we implemented it. What are you talking about?
Uh, that's 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 borderline rationalization, man.
uh,
Uh, borderline. Like you're not
but it's
wrong.
true though.
You're not
It's true
wrong.
though.
But like that you know what I mean. That's like I said, borderline rationalization. Okay, last attempt. Again, why do I am having the groovy language? Like, what this has anything to do with anything? And your audio didn't go through.
I don't know why Groovy was mentioned. Yeah.
Uh, design implementation to extending C. Metaprogramming. Objective-C adds objective-oriented programming, dynamic typing, and reflection, but reflection is runtime. Provides runtime support for reflective features, where C++ adds only a small amount of runtime support. An object can be queried about its own properties, whether it will respond to a certain message. In C++, this is not possible without the use of external libraries. The use of reflections by a wide distinction between dynamic features and static features is decidedly geared toward runtime decisions.
There you go.
Tururu, tururu. Yeah,
X-Files intensifies.
yeah. So I guess we're gonna have to go with my way. But I want to learn the other assembly anyway. And later you can make a elevator chime feature complete, and we can do a talk showing the differences actually later. Like, how did you have to approach this in an Objective-C, and how you have to approach it in Zig, because fundamentally different perspectives on how to do metaprogramming. That would be an interesting talk. Um,
Or how
or
Marinho implemented an entire new version of Chime in a weekend because he was bored, essentially.
but that's gonna be in a weekend because you're gonna have in order to make it feature complete.
Yeah,
Uh,
I need to add parsing and I need to add a bunch of stuff. I only have the actual runtime parts.
yeah. Okay, so I guess it's time. I think everybody's settled on that we're gonna have to do this way because we don't have metaprogramming. 2 weekends then. We don't have
Um,
the. Oops. We don't have the thing. We don't have compile time metaprogramming. Okay, so let's start. Um, let's just start by looking at. I want to use FASM.
Not NASM.
Yeah, NASM is more bloated. Oh wow, they have very interesting programs in here. GTK in assembly. Unreal Engine in assembly.
Calling Java classes from assembly.
Dude, that's hilarious. Yeah, but I think this is a little bit too overkill, man. Like 3 kilobytes. I'm fine. So, FASM tutorials and examples. That's what we want. Yeah. I'm not a fanboy. I just saw it that Zosin did the comparison. Yeah, he compared NASM with FASM. MASM. What the heck is that? MASM. Is this Microsoft Macro Assembly? Is this a thing? Let's read about it.
Just
It's an
use AGLA. Problem
it's
solved.
an GLA. GLA. I don't think
No,
that's what you want.
HLA. This.
H. Oh, this one. HLA. How hard it is to write in it?
I have no clue. I just know about this because it's in the public domain and I was looking at it when I was reading about the unlicensed a long time ago.
Okay, this is okay. Do you want me to read this book, Nathan, instead of just doing FASM? That's that's something. NASM is worse. That's what I'm saying. It's harder to read to write programs for NASM. I'm not being a chill of Zozing or anything. I just telling you a fact that he did. He compared the both of them. There is a stream on that. Do you want macros? We don't need macros.
You just need compile time code execution. Yes.
What do you mean, man? Man, Nathan is just saying nonsense to me. I have absolutely no idea what you mean, Nathan. That's not how it works. It's not because you don't need macros that you should not use FASM. That's not how it works. But again, I don't understand. I don't understand. Yeah, that's pretty much it. This. If you are on macOS. Yeah, the structure is the same between them. Between FASM and ASM. This is syntax, I mean. This is the same. Just use the PDF examples. It is the same docs, man. Both are PDFs. Not them being a hater. It's just comical. Just comical, man. Um, they have examples, you say. There's no difference into looking into a PDF and a web doc. Okay, that's just nonsense. But oh well. If it pleases you more, Nathan, I'm gonna look at the PDF. Uh, debugger, data representation. Okay, here's the deal. So example. Oops. Now was there something there? Example program. Oh, okay. So that's how you do without declaring the string. I see. There is nothing of downfall here. Yeah, all of them have a sectionals instructions. I hate haters, man. They just seem like nonsense. I don't have any preference actually. I just know Phasm is simpler. Yeah, we don't want an example per feature, Nathan. We want a full-blown program like this. Like this. We want something like this. That's it.
You want something like what I wrote for Chime, using Chime syntax,
Yeah,
except for x86.
yeah, because we need to know the registers, how to call them, and there's a convention and stuff.
That's the beauty of a stack-based language. You don't need to care about register names.
Uh, that's true. I can deny that. That's a feature of the stack-based. That is definitely a feature. No, for us as well. It was not that hard to implement, Nathan. It's fine. The only bad part was the packing and unpacking of stuff. You don't have to compile it. We could just settle on having an interpreter. So it is what it is. Or do you mean compiling it to like Chime bytecode? We already did that. That's not what we are doing because you already did. No, not compiling to x86. We compile to Chime bytecode. There's already bytecode being produced. And that's why Marin was mentioning the Zig stuff, because it would just be a matter of changing the target. Nah, that's a Chad sentence, but not really. Python is still popular, man.
It's not. It's not. Real programs have hardware made to run them natively, like Chuck Moore does with Forth.
Yeah, that's true. And we are compiling. We just don't have the hardware, right? So the bytecode assumes a specific architecture of a computer that is not produced. The only interpreter you need is the CPU. Yeah, that's for sure. But that's the thing. We don't have the CPU. We could ask the Chinese to make it though. Like we could program an FPGA or make a PCB. You have one that runs x86, so use it. And that's a bad argument. That's fine. Um, okay, let's just start writing an assembly already. So this is gonna be a hello asm. I'm gonna grab this program, throw it in here. I do have a mode for it for some reason. Okay. And we also need the toolchain. So let's go to the flake. Let's go down here. I'm gonna just put NASM in here and see what happens. So let's see.
If we were to follow Nathan's argument, I have a Nintendo Switch that's an ARM processor. I also have a smartphone, an Android phone, which is also an ARM processor. So we could, following his arguments, compile to ARM, and
No,
that
but
would be
his argument
valid.
is bad anyway. His argument is just, oh, you already have it, so just use it, even if it's bad or worse, or you think it's less interesting. It's bad. Argument. Bad. Okay. Do I have NASM? Yeah. Holy crap. Um, so can I run this? That's not really what I want.
I mean, we could go look for an FPGA and actually implement
No, I
the
said
Chime
that.
architecture.
We could use an FPGA or ask the Chinese to make a PCB. Nathan just doesn't know. Okay, so we managed to make it work, right? So NASM examples. NASM sample programs. Okay, so what is the most difficult thing that you need to be able to do, Marinho?
We have to decide on the stack sizes.
Oh, I see.
Because in the current Objective-C implementation, they are implemented as growable arrays using Objective-C mutable arrays, right?
Yeah, in here we're gonna have to make like at least on the first glance, we're gonna have to make like a size, right? So like, uh,
Yeah.
what's the
In the
maximum amount
Zig
of program?
version, yeah, in Elevator Chime, we I actually arbitrarily decided that the stacks will be 64 elements deep
Okay,
because that
let's
felt
actually
like
do that. So we're gonna have something called um, data stack. Oh fuck, what is the convention, man? What in the fuck is a convention?
I don't know.
Fuck. Okay, wait 1 second. NASM assembly examples. NASM. Okay. So what do you do if you have compound words? Are you serious? Those are the examples? That's bad. Oh no, there is in here. Start here. This is exactly the same one we were reading. Hilarious. Oh, it is Camo case, apparently. Okay. Um, so as far as I can tell, in order to make, you need to do like the word, right? So we want how many? We want 64, right? You said what? 64
The
deep?
words, the words is for
For separating an array of words, as far as I can tell.
no, but which the
It's gonna
word
be
size in
64
this case is
bits. It's gonna be 64.
gonna be
It's
64
gonna be optimized. That's fine. But I want to make it the words
Man,
because it's gonna be easy to walk through the words instead of walking through the whatever.
but doesn't x86 64 have like instructions that allow you to increment by I don't know 4 bytes at a time, I think, for a half word?
You're right. So half word memory allocation NASM. Okay, question regarding words. That's not. Oh, here. The assembler is correct. The literal value is 32-bit longs, but the conversion to the word truncates the value to the 16 significant bits. So DW is 16 bits? I was so sure it would be 64. So this is 16 bits.
apparently.
Okay, so we need to know, maybe the PDF has this now. Now the PDF is going to be useful. How do you make, there should be a section. Um, there should be a section about
Word
that.
16, DW is 32. Oh, so it's actually following the convention like from ancient x86 from when it was 16 bits. Is that it?
I believe so. How to make a constant. Constant in NASM. NAS menu. I want a constant. Oh, it is just the same. So max stack size 64, right? '64. So data section here. Oh, here, there. Oh, it is not. So the Stack Overflow post was correct. It is DD. Cool. Good to know. So this is also how you do it. You just put the number there. Okay, so that should be it. How do I use another label though? It's just like just referencing the label. Oh. Oh, I remember now. The data and the BSS sections. The difference is that one of them needs to be initialized, right? The initialized data must be declared with section data. I see. And the BSS section is initialized data. I see. But is that how NASM works though? Because I don't see any explanation on that. Yeah, this website is saying that DW is 32. Right, Marinho?
Uh, no, it's not actually.
Oh no, this is this
It's still
is
bytes.
this is a byte. So this is 16.
Yeah.
So DD, so this is 32 then.
Yes.
So the PDF is right. Question though. Uh,
Wait, did I just see something? Did I just see a triangle ASM? Oh, but it's not the same triangle that we have for Chime. This writes a triangle of asterisks.
Yeah.
Okay.
But I have a question though. To reserve space without initializing, you can use the following pseudo instructions. They should go in a section called .bss. You get an error if you try to use them in a text section. So this is how you do the stack then. This is how you do it. I see. Okay. Um. Oh, the section goes in the middle. That's so annoying. So section BSS, and then in here reserve 64 bytes. We want to reserve 64 words, right?
Yeah, 64 words of 32
32 bits,
bits
right?
each. Yes.
Um, so how does, what is the pseudo instruction that does that though? Probably the PDF has it. Yeah, here. So res d. So you want to have res d, right?
It's
And this should.
red, but they mistyped it.
Let's see if this compiles. Does this compiles? No. Attempt to reserve non-constant quantity of BSS space. That's interesting. So how do I reference something else? Oh, variable declarations, they don't have column. They don't have column, but this thing has column.
Because it's a label for a location.
Ah, yeah, I think you're right. Does this work? No.
Remember when we have to do this separation between compile time constants and runtime labels in Chime as well?
Yeah. So Nathan wants us to go to section 7.8 here. Yeah, you see here, they're doing exactly what we are doing. So the label, then this, then this, which is exactly, you don't need a label, no column. Yeah, but I removed the column. See? This was already here. This was already there. What do you mean? Oh, this? You mean this? We don't have a column there? No. Attempt to reserve known quantity, line 24. Yeah, so this apparently is the problem. This apparently is the problem. So how do I use the
Maybe
constants? We just use them normally. Hmm. Go on, Marinho.
maybe you don't need the DD instruction to define a constant. Maybe we're doing that wrong.
Oh, but he's doing that in the PDF. Look here. See? No, the message needs one
Okay.
because the message is a label. Nathan, look
Oh, no, 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 no. Look, it's above. It's above. Go back to the PDF.
where.
See, define constant success EQU 0 and sysexit EQU 60.
Oh, I see what you're talking about. So what is the definition of EQ? What is the acronym? So EQ,
It's
eBay,
probably equals.
NASM. What is the difference between EQ and DB? Uh,
Equate. Okay.
it does actually allocate space, 1 byte memory, allocates 2 in there and sets length to be the address of that. Oh, okay. So you're totally right, Marinho. So we need to put EQ in here, right? Marinho?
Yeah.
Okay,
Yes.
let's see if this works. Yeah, it works. Okay, that's progress. That's progress. So what else do we need? We need the return stack, right? Oops.
And we need the instruction stack as well.
So this is going to be the return stack.
This is already different from the Zig implementation, by the way, because in there, I actually defined the return stack / instruction stacks differently. Here, it's easier to just have them as separate stacks. But over there, I actually have them as a single stack, where the value that they contain is not an i32, but something I call a return frame, which is just a pair of i32s, essentially.
Wait, I'm confused. We need the instruction set. Isn't the instruction stack the memory?
No, it's not.
Why do we need an instruction stack?
Because when you fetch the instructions, you fetch an entire word which contains 6 instructions, right?
Yeah.
And when you call a function, you may be in the middle of a word, so you don't want me to throw that
Oh,
away.
that's to save the remaining ones.
Yes.
I see. That makes sense. I have no idea why Emacs is doing this. That's a little sus. Okay, so we have these ones. I think we also need some sort of how can I say? We need. Why is it like that though? I don't understand. Is this because we need to align these things? That can't be right,
Maybe.
though. That completely can't be right. Is the convention of assembly to be in the middle? Oh, just labels start at the beginning, man. Everything else goes in the middle, indented. I see. So I think we also need registers, right? So we need a PC register.
Uh, can't those just be actual registers in the CPU?
They can, but then we're gonna have to remember and be careful to not pick registers that are for function calls, for instance, or syscalls.
But in that case, can't we just do an actual normal function call in assembly?
That's the thing. I never did this before, though I watched quite a bit. So let's try that. So how do you make a comment again? It is like Lisp. Yeah. So the PC register is gonna be something. We also
You
need
have it
the.
backwards, by the way.
What do you mean?
It's not that assembly comments are like Lisp. It's actually rather that Lisp comments are like assembly.
Okay, I didn't know that. And we also need the str, right? Register. That's gonna have to be something else. Actually, the PDF probably knows that. What are the registers available for whatever? Uh, CPU registers. Right. I think we should use the ones that are numbered because I believe they are usually not the ones in the arguments of the syscall convention. Um, because these ones, rex, RCI, RDI, they are used for
Those are
syscall things.
those are 64-bit registers, though.
No, but you can use these ones. So I propose
Yeah.
for R14, how many registers do we need? We need ICR, PC, and
You may or may not want a register for the top of the stack. That's optional. It's faster if you have a register, but then it's also more complicated.
okay, so let's just go with R14D and R15D. Those would be the ones for our registers. That's nice. That's pretty interesting. And
We
again,
also need the
just a
we also
moment.
need
I just want to say that we are doing this because you're going to have to generate this, right? So you're trying to understand where the pieces, right? That's my point. Go on, Mari.
yeah. We also need we have the program counter, we have the ISR, we need the A register as well.
Oh, there is the A registers and the R register, right?
The I register is just the top of the return stack.
That's true. So R register. I actually want to make these the 15. 1, 14, no, 14 and 13, right? So if the one is the top of the
See,
reg, if the other one is the top, we're gonna have to deal with that later though. We're gonna have to create an expression using this thing. Right. Okay.
oh boy, we're gonna be neck deep in register management things
Do you
very
think so?
soon.
Because we are not using the ones that are like reserved. We're just using the ones that are available. I believe.
The problem is when we go to do instruction dispatch, actually.
Hmm. I see. But
Because for
let's try to make a
instruction
sum
dis
program using these things.
because like for instruction dispatch, you need some temporary space to look at the current instruction, but you can't just use the ISR for that because the ISR holds the instructions that you will execute afterwards. So
But can't we use a different register?
yeah, we can, but then we have to remember that we are using a different register.
No, yeah, I understand that as a problem. I do.
And
No,
that's why I prefer stack machines. You don't have to deal with this nonsense.
you have to deal with the different nonsense, which is having the stack in your mind. So for me, it's just a trade-off at the end of the day. Because in here, you at least are writing stuff. You're writing the registers. You don't have to have a mental stack that only exists in your mind.
But in the stack case, the behavior is local. Like the top of the stack will be accessed first, and if you want to go deeper than that, you have to be more explicit. You
Yeah, but
see,
that doesn't change the argument. The argument is still the same. You
it
have to
does because
go.
with named registers, each register is effectively a global variable. You can't reason locally about them.
That's correct, although it doesn't change the argument. The argument is if you have a stack, even though you have limited access to it because you need to think locally, as you said, with the top of the stack and stuff like that, that is still a data structure that is only existing in your mind.
No, it's actually a data structure that exists in the CPU. That's the point of being a stack machine.
No, that's not true actually. So when you read this program, I'm not seeing any stack in front of my eyes right now. There isn't a stack in here. Where my mouse is going, there isn't a stack. But I'm reading this, and the meaning of it is to put stuff in a stack that is only existing in my mind and implemented in the level of the interpreter. But I'm not the interpreter, right? I mean, I'm the user of this assembly. I'm reading this. I'm trying to make sense of it. And there's no stack, there's no visualization of what the heck is happening. In here, at least I have a name to anchor myself.
There kinda is. If you look at literal plus, you're basically saying, okay, there's a literal, there's another literal, and there's a plus, which will take the two literals, right?
Yeah, but what
They're
this
right next
means?
to each
What this
other.
means actually? What is
That's the
happening when
first
you do
number.
that? I know what is happening when I do this, but when you read
Because you're
that,
used to it.
no,
That's because you're
the
used to
argument
it.
goes this both ways. When you get used to it, it doesn't really matter. I'm just saying that it is not like this is perfect. This is not perfect. This is also not perfect. That's my argument. Both of them you can get pretty fast if you get used to them. For instance, you are really fast doing to the point of doing stuff like this or stuff like this. So I completely believe you that your brain has already been accommodated to having a stack in your mind, and that's fine. I'm just saying that you cannot say that, oh, this is perfect in comparison to this. No, it isn't.
I have an argument actually that weighs in favor of the stack machine model.
It
You
is
can
simpler.
interpret the thing on the right. The argument is that you can interpret the thing of the right in terms of function composition. That's much harder to do for the
I
thing on the
completely agree
left.
with that. I completely agree with that. That's a point in favor of the stack based. I agree. Aside from not having global stuff, that's also a point in favor of it. But the fact that I need to keep track of these things in my mind, and it can get deep, right? Maybe I need to remember what is in the 10th position of the stack because I'm gonna
But then
do.
you just have bad data flow.
No, no, no.
It would be my argument.
Okay, that's fair, but you can do the same. Like you can program this bad and you can program in this bad, both of them. Um, but that's something that I don't have in here. I don't have to keep track of 10 values in a row in my mind usually. You can because you have access to memory, right? So maybe you're gonna write 10 things in this piece of memory, and then you're gonna have to remember that as well. So again, you can have the same problem in here as in here, but I think the benefits of this, once you get over having to remember the stack yourself, I think this scales better because you have function composition of the box, and you only have local stuff, local scoping. You don't have, well, you kind of have global stuff with these compile time variables, but that's like, this is not a variable, this is a constant, so it's a global constant.
You can have pointers in both sides, so I would think that's not much of an argument for either architecture. But yeah, you are correct.
But anyway, so I want to transpile this version, this program in Chime to this other assembly in here. We always gonna have to add this section. Um, so let's see. Okay, so this is easy, right? So this is just going to the data section, writing things, putting
First
EQ
number, EQU.
34, and then second number, EQ 35. That's easy. So we
Yep.
already have a one-to-one mapping between compile time constants and what's going to be in the NASM version. Next up, which is going to be the more troublesome, is the instructions, right? So I think there should be a way to do something like literal label, and then we do something in here, right? Then we do something in here.
Is there a convenient way to do bit packing in x86 assemblers in NASM, I guess?
Bit packing.
Because that's bit packing, yeah. Because that's what we're gonna have to do. We have these 5-bit
Here.
integers, and we have to pack them.
Can I allocate n length bits in memory? I think the answer is no. Yeah, no. You can use words, double words, or quad words, but there are bit test methods that you could set bits in double words and up. Good luck finding an example or someone who actually knows how to do that, though. My thoughts on it. So I think
Wow, that's
I think we should look at the book though, because this is a very deep question. What are the bitwise instructions of NASM? So there
maybe we
should be a
actually don't
chapter.
have to do that. Maybe we actually don't have to do that in the emitted assembly. Maybe we just compute the bit packing on the Chime side and say, okay, this sequence of instructions actually corresponds to this word. Because we are already doing that anyways, right? We
No, but
can just
it is
reuse
kind of the
that
opposite,
machinery.
right? It is kind of the opposite. In Chime, we have like, we know that these 32 bits, so I don't know, blah, 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 blah. We know that these has six instructions, right?
Right.
We need to unpack those in order to discover what are them individually. So are you proposing for us to do this unpacking in
No.
the
What I
Chime?
mean is, no. What I mean is, in Chime, we are already parsing the literal plus halt and converting that into a number that we can write in our memory image, right? And we
Repeat,
just
wait.
reuse that number.
I got distracted. Could you repeat that, please?
Like in Chime, in the Chime assembler,
Yeah.
we are already parsing the literal plus halt and
Yes.
converting that to a number, right?
To something like this.
Yes, we are already doing that on the Chime side. Can't
Yeah.
we just reuse that number?
Why do we want to reuse that number though?
Because we have to write it in x86 somewhere, right?
That was not what I was thinking though. Let me try to explain what I was thinking. You can do what you said, but here's my pitch. Why not for every single symbol, every single instruction, we're gonna pack in the text section because this is gonna be a function of sorts using gotos. Why not create a function for each one of the things, and then when you are already unpacking the program, you just use them. You just use the same labels. So for instance, in the literal, we could say that when you call the literal, when you do a goto to a literal from the main entry point, what we're gonna do, we're gonna actually do, I don't know, assume that is in the Actually, there is a convention for that. I think maybe it's rex. So maybe the argument it is in rex. So we're gonna pick the first number out of rex and do something with it. So in this case, we're gonna put something into the memory, right? Or something along those lines.
Yeah, the problem with that, remember the self-modifying code example I wrote?
Yeah.
If you compile each instruction as a separate word in memory, that's not gonna work.
That's not what I said. Let me try to. Maybe I am missing something, or maybe you are missing something. Let me try to explain differently. So my point
Okay.
is that for each instruction, we're gonna have a sort of like a function in assembly, right? Which is basically
Yes.
gonna re-implement this, right? Each one of
Oh, you're
those.
talking about emitting each function, but only the ones that we're actually going to use
In
to
the
save
first
space on
moment,
the
I
final
would spit
binary.
all of them, but we could optimize to just spit the ones that you need. So my idea would be to have because
Actually,
go on.
actually, technically, we do have to split all of them all the time because, again, self-modifying code. That's unpredictable.
Ah, okay, that's unfortunate. But again, this is just an initial proposal, just because I think this would be easier, because this is looking pretty similar to our version, right? Because in here, this is an extension of an object implementation, which means that we have access to at least in this scope, it is global. So we have access to a data stack, we have access to registers, we have access to A registers, R registers, we have all of that. So why not just port each one of those to an assembly version using almost the same thing? It would be easier because this has error treatment, right? This throws exceptions at
Yeah.
prep. We could just do the instruction. And if it explodes, it's your fault. We don't care because this is like x86 assembly. Nobody cares.
Yeah.
Or we can put some -1 in the return stack or something like that. And then the caller needs to treat that. Right. Um, so I was thinking about doing like that. So for each one of those, we would have a label in here that would do something and then return. Uh, not return, but like go back to where you. I think you know what I mean, right?
Yeah.
Go back to
Yeah.
where we
Yeah. Yeah.
were, and that would be it. That would be it. So we would have 31 labels in here and the main entry point. That's really grug. You can argue that, but
No,
I
but
think that's
I think that's fine. I think that's fine. It works.
no, yeah. But I'm just saying that probably there's a better way of doing that, and maybe it's the thing that you were talking about using this.
No, that's actually unrelated now that you explained your thought process. What I was thinking about was I was thinking that you would like try to do something like a threaded interpreter, a traditional forth style threaded interpreter, which is not actually the model that we have for Chime. Chime is a token threaded interpreter, which is slightly different because it packs a bunch of tokens into a single word.
Yes. Yes. Anyway, so I was thinking about doing it like that because I think it would be faster, and I think it would be easy because now we have a reference, right? We would be like using our own code as a reference to implement
Yes,
that.
I think yeah, I think that's sensible. We can certainly do that. It I don't see why it wouldn't work, so why not?
No, I'm not. I'm not. We're not talking again. We're not talking about what would work or wouldn't work in this particular case, because I think there are multiple ways of doing the same thing,
There
which
are.
kind of means that probably there are better and worse ways of doing them. And maybe what I'm
This one is
suggesting is one of
pretty
the worst. Maybe.
Oh, this one is actually pretty good because it's the most it's the most straightforward way. Um, there are probably like more complicated ways to make it more compact or more efficient or
Exactly.
whatever.
Exactly.
But then it would be much harder to read and reason about.
Yeah, and that's something that I want us to think about because we're gonna have probably to debug this at some point because we're gonna be speeding out. We're gonna have the full capability of speeding out code, but it's not gonna work when we compile with NASM, which kind of means that we generated wrong NASM assembly code, and we're gonna have to debug that. And if it's completely
Yeah.
unreadable because it's using a bunch of like tricks that only kind of like really high level chads can understand, I think we're gonna have a problem.
Yeah.
We kind of suffered from that when we were debugging Chime because numbers like these where they had no meaning. We had to convert them first. They were not in X decimal, so they were like this. So convert them to X decimal, then apply some racket functions that you have on top of your mind for some reason to understand what they mean, and then
For
debug
some
that.
reason.
Yeah, for some reason you
Why did
know
you have
those.
to why did you have to tack on that for some reason? It makes it sound like I'm kinda crazy.
Oh, do you have any doubts that you're crazy? Let me tell you a thing, friend.
No, but it's the principle of the thing.
No, yeah, but that's not a bad thing. I don't know why you're taking offense on it. That's a compliment.
Yeah, but the people watching may not know that.
Then we don't. I don't care. That's straight up my answer. Then I just don't care.
By the way, I didn't have that problem in Zig because I defined a data type called code, which is a sequence of instructions, and an instruction is basically just an enum, but it's an enum backed by a 5-bit wide unsigned integer.
Oh, that's cool.
And Zig has like nice printing for that kind of stuff built in.
Oh man, that
So
must be so
I can just
nice.
I can just see the instructions as they are named in the
That's
code. It's
so
so good.
nice. Okay, I'm
Yes.
really jealous about
Yes.
that. Anyway, so let's try to translate this Chime program to NASM because this is going to be our Godel model, our Godel
By
implementation
hand?
by
By
hand,
hand?
by hand. And then let's then go to the Objective-C code to output that for us. Um, so let's start with literal, right? I think literal is pretty okay. Um, so I think we need examples on how to make a function of sorts. Um, this is a program which has potential, so let's start with that. So move output to RDX, initial line lane, number of stars written on line so far. Um, write single star. Um, so what I want to know, what is the convention? Oh, I think it's RDX, man. Is it RDX? Hard to tell. Using a C library because you can link with those. Understanding calling conventions. That's what we want. From left to right, pass as many parameters as we will fit in registers. The order in which registers are located are for integers and pointers, so RDI, RSI, RDX, RCX. And for floating points, which we don't support, so nobody cares. So here's the deal. So I'm assuming that oh, okay, we need to save stuff. We need to save stuff. Okay, so let's save. It's not RDI, right? Because RDI is 64 bits. We only work with 32 bits, right?
Yes, we only work with 32 bits.
So we need to be aware of that. So we need that table all the time. We should definitely. There's a title, stack example.
You don't need a table for a stack machine because there are no named registers other than like A or something.
Yeah, there are only two, and that's very convenient. But to be fair, the reason that we need a table is because of retrocompatibility.
Yeah,
Here.
technically we could just not care, but then it would be hell on earth to do the syscalls afterwards.
Okay, so EDI. So okay, so here's the convention for the our registers, we're always going to call the E version of them, which is nice. Um, so how does that work? Can I just
By
say this? Can I just push 32 bits and it's going to fulfill the most significant with zeros? That's very interesting. So let's see if this compiles. Instruction not supported in 64-bit mode. Oh, there's
921.
modes.
Yes, because to make retrocompatibility work, they decided to make the x86 architecture modal for some reason.
Okay, no, there is a reason, because I think making all the instructions capable of interacting with all the versions like 64, 16, 32, probably that would be very hellish. So they decided to just use modes. But what happens if you are in a 32-bit? Is that just easy as doing this? 11. I see. Okay, so they did worse than what I said. They had to implement that anyway. They had to implement multiple versions of push, of move, whatever, whatever, whatever. But then they just forbid you of using stuff. That's a little bit sus. What is the size of this in 32-bit mode? What is this? Like 64 what? Wait, is it complaining about that? No, 21. It is not complaining about this.
It isn't, surprisingly.
Okay, so here's D in 32-bit mode. How the heck you ask for that? So RSD instruction here. Why does instruction produce relative address code?
RIP relative addressing code.
What is this?
It's something, evidently.
Bit 16 and bit 32. Oh, maybe if you don't want to pass a flag. Turn off optimizations. That's kind of bad. Bad way of enabling that. Oh, here it is. Yeah, but this is not answering my question though. And this is also different.
Percent define, not EQU.
Yeah, but what the heck is that? Percent? Yeah. Define is far more powerful way of doing macros, akin to the CPU processor. In your simplistic case, there is not a lot of difference. Using X in the source code will result in the constant 3 being substituted. There is a subtle difference in that EQ statements are evaluated once, when they are first read, and define macros are evaluated whenever they are encountered in the source. When you can see the difference there, between the two statement snippets. In that case, address when encountered in the code will have different values. In the first case, dollar will be the location in the assembly position at the place where the EQ is. In other words, where it's defined. In the
Oh,
second
so it's
case,
lexical versus dynamic scoping in assembly. What the heck?
yeah, I told you these assemblies nowadays are crazy. I told you that. In the second case, it evaluates the assembly location at the place where address is. Yeah, it is dynamic scoping. It is similar to what we were talking before doing the book club. Crazy. But we're gonna use EQ anyway. So now that we still have the question, I want to understand how that works. So I'm asking to do 32-bit, and I'm gonna have to convert all of these guys to the E versions. Oh, architecture of input file is incompatible.
Can you just set the NASM to 64 bits again and see if that works
No, that
with
will
the
work.
32-bit registers?
No, that I don't know if that will work actually. Yeah, it doesn't. It doesn't understand. You cannot do a push of a 32-bit thing. You need to push everything.
Oh, that's
But I want to
that's
understand the error though. What does that mean? It is saying that E i386 architecture of input hello.word is incompatible with output. So I'm guessing that this worked. Yes. Maybe the linking is completely destroyed. Yeah. So how do you
destroyed.
how do you know so how to know L format of file? That's not what I want. File. So file. I don't have it. Okay, that's probably a red flag. I need to install file. I think it comes with Debian, man. It doesn't exist in here. Yeah. So file. Okay. Oh. Oh, that's your problem. Yeah. That's okay. So let's ask the question: how to execute 32-bit ELF in 64 Linux? Yeah, there. To run 32-bit executable, you have to add to install the packages. Oh, so my computer doesn't have the retrocompatibility. I don't know if I want to add that then.
I
I think
see.
we're gonna have to. I prefer us having the burden. I don't know about you. Like I prefer us having to deal with this 64, 32 bit thing than the user. Do you agree?
Yeah, I guess.
You sound very
And
sad about
I
that.
I don't know, man. It's just I think we're going to be drowning into so much detail that we ordinarily don't have to care about.
I kind of disagree because this was the first real detail, but well, maybe I am being optimistic. I don't know.
Maybe.
Um. Okay, so the next
By the
thing.
way,
Go,
um,
go, go, go.
by the way, I'll have to leave soon-ish because I still have some stuff to do, but also because it's getting late.
That's fine. I just want to know so how to put stuff in memory. RSD NASM. Can I ask for that? Via registers. Uh-huh. But how do I index it? You know what I mean? Do we need a counter for the pieces of the stacks?
Do you need a counter?
I'm starting
Slash
to
how
think
you
that
do
we do.
index.
Okay, so how to implement a stack NASM.
Actually, actually, try to look at how to implement an array in NASA, because that's essentially how our stacks are being represented, right?
There. Okay. No. Array creation. Yeah, but this is just... Oh, here. To access an element in an array, you can use the base address, the label, and an offset. Let's say we want to access the third element of the array. So we're going to have for each of them a counterman.
We're probably going to need a register to tell us how deep the data stack currently is, and also the same for the return/instruction stack.
Well, how deep it is? Why?
Because depending on how many things are in the stack, the next thing will be in a different position.
Isn't that the counter that I'm talking about?
Yes. Well, yes, it is.
Okay. Um, okay, so we're going to have something like data stack counter. And that's going to be, or maybe not counter, but index. Maybe index is better. Which is going to be a DD because it's 32. And it starts at 0. And you're going to have that for pretty much all of them. So return and instruction. Right. So this is going to be the return stack index. Oops. And it's going to be the instruction stack index. There. There. Is this how you do that though? So mutable variable NASM. No, that's not what I want. So how do you do that? That's funny. There's a
Why?
dupe in here. There's a dupe in here. Um, yeah, but how to create index? Yeah, there. They are using the registers, but I want to know how do you make a mutable. I think it needs to be like what is there. The website also tells
I'm
us
pretty
how.
sure it's I'm pretty sure it's mutable by default if you put it. Huh. I'm pretty sure there's a different data segment for like constants. So as
No,
long
that's the
as you
thing.
don't put it
I think
there,
that if you put without the column, it's going to be constants. These they have
why?
columns because I think these are
No, but
addresses.
oh yes, the column that's the label, that's the address. Yes.
So I think that means that they are mutable if you have an address.
No, they are mutable. They should be mutable periods, if my understanding is correct. It's just that if you don't have the address, you don't have a way to refer to it.
I see. Um, okay, so you save RDI, sorry, you save RDI. We only care about the 32-bit section of it, which is fine. And then what we're gonna do? We're gonna move
Why do we have to save it though?
because maybe there's something else in the RDI that you're gonna pop back in after. It is an x86 convention that you can see it in this example here. There is I think in the
No, I
book an
mean,
example.
why do you even need to use a register for the literal instruction? Because the program counter will be pointing to the thing you want to load, and then you just have to copy that to the data stack.
Wait, I'm confused. So you're saying that we're gonna be
Doesn't
pointing at it.
x86
Go on.
like I guess what I mean to ask is, doesn't x86 have some instruction to move data from one place in memory to another without
Yes.
having to use a register?
Yes, they do have.
Why don't we just use
Move
that? Then we don't even need to use a register for the literal instruction.
memory to memory NASM. I don't want it via registers, but let's see if this helps. Uh, Actually, instead of searching it, let's just try it. So I think the convention is is it destination then source? It is destination then source. Okay. So we're gonna have to do something like this. So we want to move from the PC, right, which is R13D plus uh, plus.
Nothing. It's just whatever it's currently pointing to.
Okay, so it's this, and we want to put that on the data stack index
I think you do
plus.
need the square brackets though, because you're not moving the value currently in the register, you're moving the value the register points to.
Makes sense. Then you're gonna do data stack index plus the beginning of it, so it's the beginning of the data stack.
That I think that may need to be the other way around, possibly.
No, this is the source, and this is the
No,
destination.
I mean the plus for the destination. I think the data stack may need to be on the left, possibly.
Oh, that would be very sad.
Why?
Um, because it's kind of weird. It's just a plus. Why they ordered this matter? It would be weird. But let's try it like this first. So this is basically a move. Calling a literal is basically doing a move, right?
Yes, you're moving the next. You're copying the value that PC points to into the data stack, the top
Yeah.
of it.
Yeah. Okay. So now let's do the plus because we only have three
You also need
instructions.
you also need to increment the program counter afterwards, by the way.
Ah.
And
Okay.
also you have to adjust the data stack index so it's one higher.
So it's inc R13D, and does it work like that? Can I just do data?
I don't think you need the square brackets
Do
if
you think
you
it works like this?
do.
For that, let's just try to see
Ah,
what NASM thinks of this program. Okay, so line 21. So it is saying multiple base segments. Um,
maybe try reversing the data stack and the.
if that works, I'm gonna be. Yeah, that's not the problem. That would be hilarious. Um, so how
Okay.
to access an array? So that's basically this guy again. But the guy's doing this. Okay, so let's see indexing array with
Oh, it's because the data stack index is not actually a register, right? It's a memory location. So when you write the label, it will interpret that as the address of the label, not the value in that address.
yeah, but can we dereference that somehow, maybe with extra brackets?
I think you need the dollar sign and before the index. I think. I might be
Dollar
wrong.
sign. No. Okay, so indexing array with memory value. Here. No, that's Golang. I forgot. I need to put NASM. Array-based indexing. That's not what I want. Nazi wants all of a memory reference within square brackets. Wants all of a memory reference within the square brackets. Should be correct. But you're moving 4 bytes from memory into EX. That doesn't answer our question. So how do you get, the question is how do you get the data out of a memory region? Something like how to dereference memory region NASM. Yeah, that's kind of what I want. There is a variable.
Wow.
That's cool. There are no variables in assembly. Uh, does several things. It defines assembly time symbol variable, which is like bookmark into memory containing address of here in the time of compilation. It's the same as doing a label empty line. So you do brackets. You do actually use brackets. So that's we don't want to load to a register, Nathan. That's the problem. We don't want to. We want to see if we can do the arithmetic only using like grabbing the memory pointer and just dereferencing it. We don't want to use an intermediary register for that.
I yeah, I was kind of like x86 has all kinds of crazy stuff dealing with memory, right? That doesn't have to pass through registers. I kind of just wondered if it was possible, and that's what we're trying to do.
Yeah. So yeah, but this guy didn't help us. So I wonder. Okay, so array indexing with
What if you put the data stack index into a register? Like instead of reserving a memory region.
okay, so what you're proposing is to do move. We need like temporary registers. What are the Oh, my mouse is going crazy. What
No,
what
no. What I mean is like reserving a register specifically for the data stack index. The same way we have one for the PC and one for the ISR and one for
But
the
then we
A
are fucked
register.
because you're gonna have to have three of them. Agree with that? Do you agree?
Well, actually, we only need two because it's an invariant of Chime that the return stack and the instruction stack always have the same depth.
Oh, that's not a bad idea. So what you're proposing is that the data stack index. What are the registers again? I already forgot. Where is the book? Here. And there's another trick though. We could try to use not the dead like the dead registers, which are the full-blown 64, but you can try to exploit this. You see?
Opa.
I think that's a good idea actually. So this is gonna be. Oh, but they have interference. This is 32 and this is 16. I can't access the most significant bits. I'm very sad about that. You can't use this true of 32 though. Yeah, that's the problem. I noticed that. Well, we have more registers anyway. We have 11 to 15. So 11. So this is the data stack and this is the return stack index. So this is going to be our 15D. That's cool. So then we're going to have to move. This is going to be plus. So this is the data stack index. So this is our 14D. and you need to multiply via the size, right? So you're going to multiply that using word size, and that's going to be 32. Is this byte addressable, Nathan? Do you know? Like, do I need to multiply it via 32 because it's 32 bits, or I need to go with bytes by bytes, you know? Like 8 bytes. How does that work? x86 is byte addressable. That's not
But
really
we're
what I
asking
mean.
about if the syntax, if the NASM syntax or whatever, if it knows that, okay, data stack is meant to be like an array of 32 bits integers.
Yeah, but I said that the data stack is 32, you know? I should
You
not
have a
have to multiply
prefix.
this crap. I should not have to multiply it.
I mean, you wouldn't have to multiply it regardless because you would be multiplying it by a power of 2, which can be replaced by a bit shift.
No, yeah, but you got what I meant with that. Um, so
Unless it's
R14D.
implied, like in the register size used. Well, we're using the 32-bit wide registers, so that should be okay, probably, maybe, hopefully.
Yeah, let's see if this compiles. Aha, line 21. So this is an invalid combination, which is sus. So this is base plus index times size. Okay, so how is the guy doing in the post? Do I put comma? No, I put comma. And it is saying invalid combination of opcodes and operands. Line 21. Mm, what is wrong with this? That's a little sus.
Yeah.
Maybe it's because
Hmm.
we cannot do dereference with dereference. Whoo, maybe you cannot add on the operand. Ah, boy. Sure. So we need temporary registers anyway. What are the temporary registers, Nathan? Like the registers that nobody assumes that you can.
Those would, whatever registers are marked as caller saves, we can just use them.
Yeah, but what is the convention? There should be a convention on that.
Scroll down. It's in the next page, I think. No, that's too far.
That's too far.
That's too far. Go up a little bit, just a little bit, real quick. Da, 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 da.
Oh, we read this somewhere else, man. I remember what you're looking for. But I think this was said in the website. Where is the website? Yeah, here.
We are not following the C calling convention necessarily, but we will have to do system calls at some point, and those use the C calling convention, right?
Yes. There was a place that we found that was oh, here. So R9, R8 and R9, I guess. Okay, C calling convention registers. Calling conventions. Registers. Register preservation. Volatile. Okay, so it's EX, EDX, and ECX. So it's A, D, and C. Where are the registers? Here. A, C and D. Okay, we can work with that. Return value, call these saved. Okay, so we can use RCX. Yeah, it is the same. What you said is the same, but the 64-bit version, Nathan. You're saying the same thing as this, as what I read. So let's use EAX. Why not? Uh,
You
so
know,
go
the
on.
C calling convention is kind of dumb because you can only return one value from a function.
Yeah, but that's like that was the beginning of everything. So everybody did it like that.
No, but I mean, if you can pass multiple arguments in, the function should be able to return multiple values out. That's just basic symmetry, man.
So EAX. There, and then in here, uh, it's something like that, right? So I'm putting in the EAX this, but then I am overriding, so I need to do something else about that. Is it like this? You can always set a global thing or modify a pointer.
Yeah, but then you are setting a global thing or allocating memory.
What am I doing wrong in here?
I have no clue, Lemos.
Because what I want to do is the following, right? I want to pick the address of this, and in there I want to put the thing.
I guess they could return stuff on the stack. But then, why are you even using a register machine in the first place? If you're just going to use the stack to pass data,
Yeah,
just use a
then
stack machine.
that's true. That's true. I just think it was a limitation that people had at the time. Like nobody thought about like, wouldn't it be nice to have to be able to return multiple values? I don't think that's how people thought about it. I really do. And again, you may argue that whatever about it. I'm not thinking in the abstract. That's completely not abstract. They made the hardware of the stack. That's not abstract. And they made callee and caller conventions, so they know what return means. So it's hard to justify. It is completely hard to
Return
justify.
means tail calling a continuation,
Yeah,
which is no
that
different from tail calling any other function.
yeah, that's more abstract. Yeah, because you basically define the purpose, right, Nathan? If you're gonna do the returns using the stack, why not? Why have the registers? At least why have that amount of registers, right? So one of the purposes of having a bunch of registers is to use them as to pass arguments, right? If you're gonna use the stack to return multiple values, why not use the stack to provide multiple values as well? And if you do that simplification, you're basically gonna end up with the machine that we are modeling, basically. Because in the machine that we are modeling, there's only 2 registers. Well, that's a lie. There are 4 registers.
Actually, that's also a lie. The entire stack is basically an array of registers, if you want to get really
Yeah,
technical.
but that's like that's the implement. That's even more implementation detail. Okay, I think we're gonna call it a day, but I should discover how to make this happen though. How we can go to how to pick the address of this place here and put the contents on pointing to that place. I think my Nathan is right, and probably there is not a way to. No, but this example is doing that. You know what I mean? Oh, maybe the right side. Ah, maybe it's the right side. Okay, it worked.
Wow.
It worked. So now we just need to make two extra instructions. So we need plus. Plus picks the two values on top of the stack. Um, and put them back on top of the stack. So the first argument should be data stack plus 14D. Then I think the other one is
But that's kind of the point,
ADX.
Nathan. In a stack machine, the stack is implemented as a set of registers that can only be accessed in a specific pattern, essentially.
And this is gonna be this. So incrementing it goes deeper into the stack, Marin.
Incrementing it
I think it's the
goes.
opposite, right? To go
Oh,
deeper, you need to subtract.
yes.
Yeah.
Yes.
Ooh, that's interesting. Because there's no stack, right? It's just an array. Um,
Well,
that
yeah, in this case,
means,
the stack is implemented as an array.
yeah, that means that we need to take care of the pointers, right? We need to change R14D accordingly, which is kind of okay. I have a suggestion. So what about subtracting from R14D in the beginning? And I need to see how that's done in the website. They have it, the table. Where is the table? Here. Sub. Okay, so yeah. So you're gonna put 2 in there, and then here's gonna be +1, and this is gonna be +2. But the index is already fixed. It's already like shifted to the 2 pops. Then you're gonna do an add of EX with EDX, and then the result is gonna be an EAX. Then you're gonna move that again. You're gonna move to the top of the stack. You're gonna put the value of EAX. You don't need to increment PC, but you need to increment 14D because now there's a new value on top of the stack.
Why don't we just do sub R14D1, like, huh. Yeah,
Because
no, I'm
here's
thinking about optimizations. I'm thinking
yeah
about optimization.
yeah
Just keep
okay
it as is for now. We can
okay
optimize later.
okay. So this is how you do it, I think. Um, I want a register to track the top of the stack, no, not the offset of it. No, we're not gonna. We don't want to have a register to track the top of the stack. We have a register of the index of the how deep the stack is.
I mean,
That's
we
what we have.
could, but we don't.
We could, but we don't. Okay, so how do you How do you exit code with 0? Invoke operating system to exit. This is how you do. This is how you do it. System call for exit. So I'm just gonna put halt in here. Thank you very much, internet. And we also want to see the top of the stack because halt also does that. So then the
The
question,
halt in Zig actually only halts. It doesn't actually print the top of the stack because I don't have printing, and also because I can just inspect the final states later because it's just a regular like data structure.
okay, so the entirety of the previous program is going to be here. So hex is going to be the same. RDI is going to be the same, but this is the difference, right? So we need to put something different in here. So in here, address of string, it should be an address. Uh,
And by the way, Nathan, having a dedicated register for the top of the stack does not actually remove the need from taking the size of the stack, because we're gonna have to save stuff and grab stuff from there anyways as we do operations.
Yeah. Okay, so but here's my question. So we need to put an address in our site. Can we just put the value? How does that work? Do we really need to put an address? Because I would be quite sad if that's the case. Well, maybe I could put the address of the top of the stack, like, and then is this grabbing an address? Does anybody know? Oops.
Ta-ta.
It should pick an address. Um,
Uh, like the point of having a register for the top of the stack is to make the stack operations faster, right? Uh, because the stack operations, they work on the top of the stack, and if you don't have to reach into memory for that, that's usually better. But that also complicates the implementation a little bit, because you do need the stack backing it up. Like you can't just have the top of the stack and then no stack under it, because your mental model wouldn't work.
is this how you do that? I think that's how you do that. Okay, so here's the deal. We need to know how to do the routines now. We are very close. So we need to know how to do a ret and stuff like that. And there was an example of a printf. I'd like to go back to that. Another example.
Mm.
We're very close to have to be able to sum numbers, bros. Very close. Oh, it's call. No, but this is interrupt with C, right? Yeah, I don't want that. Don't want that. Here's how you do it. So, we save this since we use it. Count down to 0 is originally 1. Yeah, but how do I call? This is still doing C. I don't want C. Command line arguments. This is just doing a bunch of. I think we're gonna have to do go tos. I don't want to do that though. What happens if
Oh,
you.
I see. I, I think I see.
Floating points. Mm, you see the problem, Mari? We are
No,
facing here.
I was actually talking about what Nathan wrote. I don't see the problem. Okay, what is the problem? You want to print stuff, is that
No,
it?
no, I don't want to print stuff. I would like to have a way of being able to use returns and so on and so forth, but these are not functions, right? These are only labels. These, right?
Uh,
Ah, there is a way to do this. Okay, so you can always just do ret and assume that the stack is gonna have it. So we need to push that. We definitely need to push that. So how to use ret nasm assembly, how to use them. That's kind of what I want. That's not here. In Portuguese even. No, that's not what I want. Is return and call one-to-one with machine code? What do you mean? This is the same thing. Ret. Like, I need to push the return address, man. That's the thing. Just assemble into more than one machine code instruction. I have no idea what they're
Chime
talking about.
does have a return instruction and a call instruction. But they are much simpler than whatever x86 does for those.
Oh, it's just call. Okay, so I'm just stupid. Let's go then.
They are simpler in the sense of like, because the stack is implemented as registers in the CPU, you don't have to manage stack pointers and like all the metadata associated with stack frames that you have to manage, right, in a register machine. So a call literally just pushes the program counter into the return stack. It pushes the instruction register into the instruction stack, and it sets the program counter to be whatever the previous program counter was pointing to.
Okay, Marinho.
Yeah?
Now it's easy. We just need to uh, set the registers before doing the calls, and we are done. That should be it, man. That should be totally it.
Oh, you're doing a subroutine threaded interpreter. That's nice.
Well, I don't know if this is going to be the final version, but I just want to make this program here. Um, we just need to
By the
put.
way, did I
Go
did
on.
I send you that link about bytecode interpreters, or did I send that to Mageta?
I have no idea. Move. Oh, we need to put. I see what's happening. Okay, so where is PC pointing to, Marinho?
Where's PC pointing to?
Yeah, because as far as I can tell, the register PC needs to be pointing at the memory, right?
Yes,
We don't have memory.
we should.
Okay, so we need memory. I'm gonna use the same stack size for now for the memory, just for simplification purposes. And we need to load the memory, right?
Ah, see, the problem is that like
Like load. And then we should do something like um, move move into AX R11D plus memory. Uh, Actually, it's the opposite. We already know what to put because it's first number. Then move, and then we need to increment R11D. And then we're gonna move this second number. And then we do a ret. So this is load, call, load. So we call load, put into the memory the 34, then the 35. Then we're gonna call literal 2 times, which basically gonna do is basically gonna pick the value that PC is pointing to, which is this, which is the second number. So it's gonna put the second number on the data stack. It's gonna increment R11D. That's okay. So I think we should not do that. And I'm gonna rewrite this to be more explicit of what we're
Okay,
doing.
Lemos, here is a link for you to look at some point because it's suddenly very relevant.
Why?
Because it will tell you precisely what I was trying to tell you about self-modifying code and how that affects the behavior depending on how you compile the Chime code to whatever.
Okay. Let's see just if this works though. So you have load. So that's gonna put the first number and the second number in memory using the PC, which is set to 0. We should actually say that. So move R11D, move 0 to that. Actually, I'm gonna do the low level way. Okay. So PC starts at 0. In the first position of the memory and the second position of the memory, you put the first number and second number. Then you call the literal, which is going to grab that out of the memory and put that in the data stack. You're going to do that twice, incrementing PC. Then you do a plus, which is basically going to grab the two top things on the data stack, sum them up, put them back at the data stack. And then you're going to call a halt, which is basically showing us the top of the data stack and ending the program. So that's it. Now, does it work? I have no idea. So line 28. Okay, so that's not how you do an address, apparently. So move address to register NASM. That's not what I want. What am I doing wrong in there? That's the question. Do I need to do this twice? I can't do the math in here? That's so stupid. But okay. So add RSI. Yeah, that. Okay. So 38 and 39 here. So operation size not specified. Do you have unnecessary brackets? You can use the layer instruction, I guess. We're gonna make this look better later, that's fine. So how to move constants to registers? NASM. Yeah, that's what I want. Oh, I need to say. Ooh. I need to say the size though.
Oh,
Okay, but how the heck do I do that? So, where is the book? Here. So, keyword. Yeah, quad word example. So if I want to move, huh, double word example. Okay, so it's the word. So I just put the word in here. How does that work? Maybe I need to put that before the word. Hilarious. That's the perfect way to end today's stream, though. We played a little bit, so I'm gonna finish the stream.